Good morning. Please, science students should come closer, please. Is there only two of you? Okay. All right. We'll start with physics. We'll start with physics. We'll start with physics. Where did we stop in physics? Motion. And where is specifically? Where specifically? Were you not there in my last class with you people? Hmm? Okay. Let me see where I stopped. In my lectures with people, not with other. We are still in motion. Where exactly in motion did we stop? So we'll continue from there. I gave you an assignment on relative motion, right? In my last class with people, I gave you an assignment on relative motion. Check your notes. That means if you cannot remember that I gave assignment, that means you did not do it, or maybe you are not in the class. You're looking for it. Look for it now. I gave an assignment in my last physics class with you. A calculation. Did you attend a class where we did a calculation on relative motion? Are you serious? Let me see your notes. Let me see your notes. Huh? See it here now. You know the assignment. So what do you get? 15 kilometers per hour. Okay, you come with different notes. Wow. Let me see your own. See it here now. See it here now. You know the assignment. So if you come to a class and an assignment will be given, and you go back and you can't even remember at all that assignment was given, it's a problem. Don't you think so? It's a problem. That means you are not studying. That's the meaning. You are here for a lesson to prepare for exam that will soon take place in about 3 months' time or so, and you're given assignments. The first thing to do is to go home, do the assignment, even study more on that topic. That is what it should be. That is what it should be. Please let us not continue like that. It's not a good sign. Do you hear me? It's not a good sign. I can remember the assignment I gave you. I said we solved the first one. Then the assignment says that 2 boats are moving in a river. Boat A is traveling upstream at 15 kilometers per hour, while boat B is traveling downstream at 20 kilometers per hour. Huh? Is that what? You solve it. And you kept quiet here since. So what keeping quiet? I said I didn't. Okay. That note is at home. So that means if I detect it now, you can help us here. Right? You tell us what you did, right? Good. Let me call the question for you so you can tell us what you did. The question says 2 boats are moving in a river. Boat A is traveling upstream at 15 kilometers per hour, while boat B is traveling downstream at 20 kilometers per hour. The speed of the river current is 5 kilometers per hour. What is the relative speed between the 2 boats? So tell us what you did. Let me hear what you did. We have 1 minute to do that. Your questions in jam is higher. If you break down the number of minutes you have to, some questions I think it's an average of 45 seconds or so. I don't think you think it's up to 1 minute, 1 minute per question, or let me call it 1 minute. So you have 1 minute. Oh yeah, tell us what you did. Tell us what you did. Come, the assignment I gave. Come and tell us what you did in the assignment on motion. Fast, fast, fast. In our last class, we treated relative motion, and I gave assignment that starts with two boats are moving in a river. Did you? Were you in the class? No, not you. I'm talking to her because I've not seen your face before. Huh? It's not in your notes. Okay. All right. So let's look at the question. All right. So the question says two boats are moving in a river. Boat A is traveling upstream. Boat A is traveling what? Upstream. The river flows. How do you think it should flow? When you hear upstream, what comes to your mind? Huh? Upward, how?
Like up
Like this. Going to where?
going to north.
North. Okay, which direction is the river? Do you think the river is flowing when you hear upstream?
Flowing north.
If a river is flowing like this, right? So where is the river flowing from?
From the east.
Is it upstream to the downstream,
No.
or downstream to upstream?
Um,
Have you been in the have you visited the river before, or a stream, whatever you call it? So tell me, how does it flow? Is it upstream? Does it flow in from upstream downstream, or it flow from downstream upstream?
now upside down.
Are you sure?
Yes, sir.
Are you assuming? Are you guessing?
No,
Where is the
because
duster?
you can't flow from downstream.
So before you can answer this question, you need to understand what is upstream and what is what downstream first. So if you don't understand that, there's no way you can answer what the question. So the first assignment is to be able to know which one is upstream and which one is what downstream. So let's assume we can decide, we can choose any direction for the direction for the like we can make it to be like this, okay? So boat A is going towards what? This direction, right? While boat B is going to which direction? Is that what it means? So the question now says this is boat what? Let's call it boat A. Let's call this one boat B. The question now says this one is 15 kilometer per hour. This one is what? 20 kilometer per hour.
So and the stream and the river.
Then the speed of the river current is 5 kilometer per hour. What is the relative speed between the two boats? You that solve it, what did you do? You are not told us anything. No. You say you said you are
I
solve
told
it.
you
So let's see how what you okay, you can't remember what you did. Wow. All right, so now listen. The first thing to put into consideration is to check the what I tell you about a native motion, about if the two bodies are moving in opposite direction, and if they are moving in the same direction. Which one do you add and which one do you subtract with respect to relative motion? Now, if you want to get their relative speed, which one do you add? Opposites?
Add the you minus the opposite.
You minus the what?
Opposite.
You are guessing.
I'm not guessing.
I am in a bus now.
Yes,
Yeah.
like this.
Uh-huh.
Another person do like this.
Uh-huh.
That's
Minus. Don't use the knowledge of vectors here for now. You may make a mistake. I think I pointed it out that day. You are using vector. If you just use vector, we know that in vector two of them are what? If they are opposite, you do what? Minus. If they are negative, you do what? If they are in the same direction, you do what?
so okay, it's the other way around though. Yes.
What I tell you in the note in our last note. You don't study. You don't study. Go to hello.
Yeah.
That last one we solve. What that's about it?
Let's see.
Is it what? Okay, go with okay. Uh-huh.
Let's now.
Check his own because he was in class that day. Check his own. He copied from somebody. Check his own. Please, I want to encourage you after each class. Please make sure you go through what you did in class. It's very important. Eh? Because it makes no sense after everything you keep teaching simple assignment you can this is the simplest part of motion. We are still entering complex ones. What do you see? Our time is going low. It's okay. I am not happy with this. Expression on what? Good morning, how are you?
The car is moving.
Okay, can take this. Is that what?
You don't even solve any question for us.
Me? I didn't solve question for people. I did not solve.
Doesn't you right?
I did not solve. It's okay. Let us not go into that. But I'm not. This sign I'm seeing here is not a good sign, though. It's not. Don't say I only solve the question here. How can you be in a class you don't put down what is said in class? It makes no sense. Okay, I'm not just to teach and go. As I'm teaching, I'll be sure that you are following. Let me repeat what I said that day. But if you keep repeating it every time I come, we will not progress. It's small thing that compound to a great thing. True of us, small things. That small one you did in class, learn it. Next day, you do another one. Before 2 months, 3 months, you have learned a lot of things. But if you keep running around a particular thing, that one you will not even go through it. Huh? Okay, keep it there. Now look up. Let me explain again. I said that when you have two bodies moving in this direction, this one is moving this direction, this one is moving what? This direction. if you want to check the relative speed between them, the relative speed between the two of them is the difference in their what? In their what? The speed. Am I communicating? Because they are moving in the same direction. Normal vector, you do what? You add normally in a vector. But when you come to relative motion like this, what you do is this: you subtract because they are in the same what? Direction. But if they are in opposite direction, direction, you do what? You add. Am I communicating? Now, this is upstream. The current, the river currents, the river currents, which direction do you think it should go? The river flows from upstream to what? Downstream. You agree with me, right?
Yes, sir.
Because the river doesn't flow back like that. True or false? It flows from upstream to downstream. Now, as it's flowing, these boats, listen carefully, please. Are we together?
Yes,
this is direction of the flow, right? The boat A is moving like this. Boat B is what? Moving like this. Are we together? Now, the current is like this. The river current is like so that means the river current is opposite, moves in opposite direction with what? With what? With the boat moving upstream. Are we together? The river current moves in opposite direction with the what? The boat moving what? Upstream. But the river current at the same time moves in the same direction with the boat moving downstream. Is it clear? Is it clear? Now, to find the relative motion between the two of them, you should first of all find the relative motion between the river currents and boat A and keep it. Then find the relative motion between the river current and boat B and keep it. Then whatever relative motion between the two of them, you find it for the boat A and what? Boat B. Now, the relative motion RM between boat A and the river current, they move in opposite what? Direction. Because they move in opposite what? Direction. The relative motion between them should be what? This plus what? This. Is it clear? Did you do the assignment again? Did you? You don't remember? Almost everybody did not do. I'll be asking you one after the other. Did you do it? Anybody that enters, I'll ask. Did you do the assignment again? And you're coming to change the topic. See them. Two of them. Change topic. Motion you don't know. You are saying change topic. So can you see? Can you see? But wait, are you listening? Do you understand what we mean by river currents? Does the current actually flows in the same direction with the direction of the river? Yes, sir. I'm coming. Yes, sir. That's a question. No, that's normal. We are talking about current electricity now. Flow of river. Yes. In this sense, is the current actually in the same direction with the flow of the river? Currents. When the river is flowing like this, is that what?
That is where you are going now.
What?
If you are going upstream now. are going, yeah, with the current of the river, looks like, and you are going
Upstream.
upstream.
Mm-hmm.
So you follow that is your direction that determines if you are going downstream or upstream, or you are going
I like what they are doing, no, but
yes now.
what do you think? After this, there are some.
There's no
What do you think? No, no. River current. Does actually? I made a statement. I want to us to think deeply into. Do you think the river current moves in the same direction with the direction of the river?
No,
Why do you think so?
because
like
the
what do you
like
think
you might be inside boat now. Let's say for instance, you might be inside
Both
going
are here.
towards the let's say you are going to Calabar and the river point is going to
So I'm sorry. I'm questioning what I said here on the board. That the river, that the current is in the same direction with the flow of the river. That's what I'm questioning. So do you think is I want to train you to think radically, not just to think how do you put it logically, sorry. Not just anything said you agree. Do you really think it flows in the same direction or in opposite direction?
determines where you are going to. You are going to
The first is to understand what a river current is. Am I competing? The first question now is to understand what is river current and what is the flow. We have agreed that it flows from where? From upstream towards downstream. We agree on the other one, right? Now, which direction is the current? Is the current also from upstream to downstream, or is it opposite?
that if it's
Feel free,
not
feel free, take it up.
if it's not opposite now, how will you do it? I will
Wait, just wait. Forget about what I'm doing. Forget about what I'm doing. Just ask question. What is river current first, and which direction does it flow? I'm doing assignment with you. This assignment I gave you. You refuse to do it. We are doing together. So I want you to participate in it.
I want to give up and I'm paying
Because if you don't understand if you don't understand what river current is and what is upstream and downstream, you can never solve this question. You make mistake. Hmm? Who can tell us? Did you see anything? So what you want to say?
like river
To and fro.
yes,
Why? Why do you think so?
river is not understandable.
yeah, like
River current.
wave.
Huh?
River current is
Uh,
not
okay, here now, what do you think happens here?
everything.
Huh? I'm with you. Continue. I'm with you.
Going through and through.
Yeah, means that it's also like
With what?
the upstream is directly with the current of the river, while the downstream is
What do you see?
just
Then you shall be the one you see there.
Sorry, are you looking it up? Let me show off what she's doing. I'm looking it up. If you're not, let us know. See how she look at it. I thought she tried to help us. I didn't know she was doing that. Sorry, continue what you are saying. I'm listening.
but instead of plus one and minus one, it's also same since the current is
Okay. Please help me get a ticket for me. Ask what? So what do you see? I will not tell you.
Why?
I'm tell you. Because I am not happy you would not do my assignment. I'm not happy, seriously. Forget I'm laughing. I'm not happy. I'm not happy.
I'm going that. So that day where I follow up. It was at that. What's the meaning of
Now you are thinking. I like this. Now you are thinking. Oh yeah, think. Now you are thinking. Oh yeah, you are not thinking anything. You're just playing. The play. Continue. Continue. Go to what I did. I like what I doing now.
And the boat is coming.
Yes.
So if the boat is going, the water will like when the water
Wait.
the water is baptized, the boat will opposite.
So the one moving upstream is moving opposite to it. Is that what I'm making?
So let's have that boat is coming towards as the one coming like this is moving towards the backward, moving the same direction.
Okay, good. Do you have anything to tell us?
Like riverside.
Actually, river current can move. Basically, it moves downstream, but sometimes it can also move upstream. Just as you say, depending. If you have tide and winds and other things, it can make it to move. It can make it to move under normal circumstance. All things being equal.
Yes, sir.
Am I completing?
Yes, sir.
It can move. It moves downstream under normal circumstances. But sometimes there can be tide. There can be wind or something else. There can be other force that wave. Or there can be other force that can make it move upstream. But basically, under normal circumstance, following the natural course, it moves downstream. Are we together? So, please allow them. Yes, allow them, please. Allow them. Allow them.
You know those sleep that
If there is tide, it can move opposites. But under normal circumstances.
All those people that
Yes. But basically,
it's moving like opposite sides. And the boat is moving
see it now. It's moving to the downwards, right?
Like, they said force can make it upward like this. I said, what if the river current is moving like this?
Okay.
And boat A is moving
So, okay, you're not asking of the fate of the boats. Basically, the boat there will be a shift in the direction. You may see them. The boat that was supposed to come here will now start having a slope. It may move like this. This is where it targets to go. Because it's moving like this, the boat will push the boat to. You can still plot the slope gradient and find the distance from here to here considering what happened here. Because if under normal circumstance, this should be the displacement. But because of how it moves here, you can use part of that theorem to find out what distance that is covered. It happens. Direction whereby the let me explain. Let me understand your question. You said what? Flow. It's true. It's true. You know what she said is that the point I'm making is this: under normal circumstances, it should move down. Under normal circumstances, but some situation can make it. It can move opposite. That's what I'm making. And you also pointed out something now. You said, what if it moves like this? What happened to the boat? Which I have already explained. That the boat that targets to go from here to here under normal circumstances. If everywhere is down, maybe what would have taken it maybe 5 seconds or let me say 30 minutes or 1 hour, depending on the nature of the river to move from here to here, because of the wave because of the current that is in this direction. You see the boat moving in this direction, so as to make up the force that the flow that is going at this. You see what? Of course, and there are other factors, not only that alone. Now, have you seen why I gave it to you as an assignment? There are a lot of concepts you need to understand first. How to do assignment is that if you're giving an assignment, calm down first. Go to the question. There are some things you will not understand. The idea is for you to study all those things, understand them before you now do what? Solve the question. So what you would have done at home is what you are now doing here. But it's okay. It's not bad. I want to use it to teach you how to do it. If you're giving an assignment, take it seriously. Go through it, get your materials, research on it, find out some things you don't understand about the question. Then you go to do what? So anywhere now you hear something like this now, I believe you have one or two things to say. Three of us. Now let us now solve the question. Since we have an understanding of what happened. So let's solve the question. Help me clean this question. Let's now solve the question. Because when I was trying to explain it, the look on your face, faces were like, I don't know what this man is saying. Three of us. So that was why I stopped and sit down to be able to explain. Sorry, you came late, you missed, and we can never go back again. I will not go back. Sorry, you came late. It's okay. Okay, you cannot go. You can now off your data. Is that what you do in class? Your phone can make or mar you. Hope you know. Yes, you can make or do what? You have what to take you to you have what to take you to a very great height in your palm. Oh. That's what they don't know. How you don't know? Of course now. You have it in your hand. But jokes apart, on a more serious note, you see this thing, you have the world in your palm. There's nothing you can do for, no information you can do for you. But basically, get a percentage of you use it for nonsense. Use it for the negative aspect of it. So, change the orientation about food and internet. and you see that you go far. It makes a lot of things. It makes your study easy. It makes your lecture, even your lecture. That's why in my classes I try to in my class dual schools I tell them, please, before you go to my class, make sure you have data. I make compulsory you must stay. Make sure you have what data, because I know that there are a lot of things. A lot of things you will learn. It's not for you to be wasting your time. Even if you must go to TikTok, go to Facebook, post go for important things that even let not go far. So I think we have laid the foundation now for this question, right? So anytime we saying from now henceforth, you want to understand me, right? Now, so let's assume that this is the upstream, right? And this is the what? Downstream. Boat A is moving up stream. This is boat A. Sorry. And the velocity is what? What is the velocity of boat A? 15 watts. Sorry, I mean speed, not velocity. Speed. 15 watts. Kilometer watt. Then boat B is moving downstream. Boat B is moving what? Downstream. At what? At what? 20 kilometers per hour. Now the current flow is what? 5 watts. The river current is at 5 kilometer watts per hour. It's 5 kilometer per hour. Now, are we together? Hello. They didn't tell us the direction of the there's a loophole in this question. Are you aware? They tell us the direction of the flow or the current. Then we just assume that it's normal. It's flowing like this downstream. So what I will do is this. What I will do is this. I will solve it if since current flow can be upstream and can be what downstream. I will solve when the current flow is what downstream. Then solve when it is what upstream. Am I communicating? Am I communicating? Now, assuming now that the current flow, the river current is downward stream. Assuming that the river current is what downstream. If you assume that the river current is what downstream, which is what 5 kilometers per hour, right? Now, if the river current is downstream, let us now solve the relative speed between them, or motion between them. Now, to do that, we should first of all work on the both A and the current and keep. Then work on what? Both B and the current and keep. We now do that of what? Whatever result we get from two of them for both A and what? Both B. Now, to solve the relative speed between the river currents. The relative speed between the river current and boat A. Remember, they are in opposite what? Direction. They are in what? Opposite what? Direction. So the relative speed, this one is moving with a speed of 5 kilometers per hour. And the boat A is moving opposite with a speed of what? 15 kilometers per hour. So they are 15 and 5 apart. Two of us at any point in time. I come here. Hey, come here. Fast. Fast. No, fast. Is that how you come here or you leave the class? Do one. Fast. Now, I want to explain something. Watch out. At any point in time, boat A is moving with 15 kilometers per hour. Listen carefully. This is boat A, right? Moving with what? 15 kilometers per hour. This is the river current. Moving with what? 5 kilometers. So they are 15 and 5. So the relative speed between them is it 15 plus what? Not minus. 15 plus what? 5. Am I computing? Making it what? 20 kilometers per hour. So the relative speed between both A moving upstream and when the river current is downstream is what? Is what? 15 plus what? 5. Which is what? 20 kilometers per hour. So the relative speed between both A and river currents is equal to what? 15 kilometers per plus what? This is when river current is downstream, okay? Is what? Downwards, downstream. So it's what? 20 what? Kilometer per hour. Are we together? Now let's look at the relative speed between the river currents and because do you know why you do this? The river current has effect on the speed of each of them. As they are moving, the river current has effect on their what? Speed. That's why you should do the relative speed between the current and the what? Each of the boats before you now compare two of them. Now, the relative speed between boat B, this is boat B moving with what? Boat B moving with what? 20 kilometers per hour, and that of the river current, they are moving in the same what? Direction. They are in the same what? Direction, like this. So boat B is here, the river current is here. So the relative speed between two of them is from here to here, which means this minus this is from here to here. That is the relative speed between the two of them. So it should what? 20 minus what? 5, which is what? 50 kilometers. Is it what? I explained that. This one is like this.
I'll give you just 5 questions.
It's moving like this. Remember, before I started doing this one, I told you something. Clear your mind of vector. In vector, if they are in opposite direction, you do what? Are you serious? In vector, you do what? You minus now. If that
One side is minus, one side is plus.
It's only the letter is negative, so you do what? Minus. But after saying here now, remove that one. Here is what you do what?
The other one.
Am I computing? I said it for the beginning. Maybe that one is computing here. Am I computing? So if you remember that one, just do the opposite. You can solve this one. Is it clear? I'm only trying to explain why it's like that. Now here, so now the relative speed between both B and river currents is equal to what? 20 what? Kilometer per hour minus what? 5 what? Kilometer per hour, which is what? 15 what? Kilometer per hour. Are we together? So
see this upstream and this downstream. What if you are giving that
A story written in form of letter is called that.
and there's no upstream there, and this one?
Episode. It's not episode.
There's no just follow the same principle now.
I mean, like, let's say this actually this upstream now and this direction that beside each other, all is come like this.
For okay, there's no boat A.
Yes.
No boat A.
Yes.
No boat A.
Both A is there. There's no this one.
There's
There's
no.
no both B.
Okay.
Only both A is present.
Uh huh.
So the downstairs is like this.
Uh huh.
Both A is like this.
So if you want to calculate what now?
Calculate it.
It's something now.
It's close now.
It's opposite. It's plus. It's plus.
It's in one direction.
Yes. Is that not what I've been discussing? Yes, is. Well, so I like see. I like what you're doing. Don't mind those that keep quiet and they don't know it and they keep quiet. Ask, you learn it, and if it enters, you don't do what? You don't enter. But is it clear?
Yes,
Good.
sir.
Now, so here is 50 kilometers per hour. Remember that on a normal, boat A is opposite direction to boat B. Now, if you now want to now find out the actually the latest speed, remember that I told you that why we are doing this is because that the current influence the speed. Remember, the speed, the actual speed. The boat B will now start moving with is the latest speed between it and the what? River current. So now if you now want to determine the latest speed between boat A and boat B, if you now want to determine the latest speed between boat A and boat B, what will we do? Are we together?
Hello. That's your black.
Let's face for the hello.
Yes, that's there. So I
No.
hello. All these girls are this girl black. Where did you get that from? I need to clean your shit. Okay, it's your own.
Who can go pick one rag on my table there?
Show am now.
So I ask a question. The question is, what is now the latest speed between boat A and boat B?
5 kilometers per hour.
What?
35 kilometers.
35, right? Yes, because
You lost.
When that name is so it's not that.
yeah, this why Vector Stephen himself. He's doing minus. You do what? Is it clear? Is it clear? So now, you call it relative or effective because that is the actual speed that is it between the two of them. Now, the relative speed or effective speed, as case may be,
Sorry about a particular rate of people.
between both what? A and what? B is now what?
35.
20 what? Kilometer per plus what? 15 kilometer per what? Hour. The answer is what? 35 kilometer.
Plus.
Sorry about a particular rate of people.
No. No.
You have said that.
Calm down. Sometimes it may not. Forget that it tally here. Sometimes it may not tally. Sometimes there may be other factors that may make it not to tally. That's why I will solve it. Do you know why? If you solve it like that, we know 15 plus 20 starts 5. But if it's something like that straight, what we are saying is that the river current has no effect on the sea. The river current has effect. Now, okay, now look up. Am I together? Remember, this one is for when the river current is down. Let's look at this. our research here, we concluded, we agreed, because I like my student to agree. Okay. With me, that's why I allow you. There's some concept I will see. I will allow you to do what, take it up in my presence, so that you will agree. Not that my lecturer said. You will not say the lecturer, that's what he said. No, that is what we researched and we saw it with who? The lecturer. Am I communicating? So that's how I teach. Am I communicating? We saw it with him. This is what it is. Now, we agreed that the river must not always be what? Downstream, right? This is the situation whereby it is what? Downstream. What if it is upstream? What happens? Let's look at it. What if it is upstream? See what happens. That means what if it's moving like that, like this, right? Yes. The river current is moving like this.
Moving one direction.
You're saying one direction again. It's downstream, not one direction. Yes, now I say a situation whereby, let's see what happens in a situation whereby it's moving like this. I don't know if you understand my point. Let's see what happens if it's moving like this. Remember, it's still what? 5 what? So see what it means now. If it's moving like this now, what it means is that here is 10, right? Are you following? I'm happy some people are following. The first step is to find out the relative speed between the moving upstream and the river currents. True of us. Which is, because they are moving in the same direction, is what? Minor subtraction, right? Right? So the relative speed between both A and both B now is, and the river current is now 15 km per hour minus 5 km per hour, which is what? 10 what? Kilometer per hour. Now, what of the relative speed between both B and the river current is now what? 20 plus 5, which is what? 5 kilometer per hour.
You know that if you are watching either
unless they continue.
or watching the film, you say something that has to go between that between both A and B. Or I don't really think about it at all. That happens. But you cannot be studying that and that's all like this.
Please, what please? Okay. Where we have the upstream and that's where. You know what I said now?
There is so you can be down with it.
So there's something that we call the power of the law. You know, most of the down with the law.
I plus what? That thing is not upstream and the downstream. Keep that you're looking. This is not upstream. This is both A and river current now. It's not upstream and the downstream. See, look at it, like it's both A and the river currents. When the river current is moving downstream, the speed between both A is opposite in direction with both A. Is it not true? Both A is moving upstream and river current is downstream. The effective speed between the upstream, both A and the river current is what? Addition. Because they are moving in opposite what? Direction. But when you get to both B, is what? Subtraction. Because the downstream is in the same direction with what? Both B. The river current moving downstream is in the same direction with what? Both B. But if you come here now, assuming that the river current is moving upstream, you want to see what happens. The river current is now moving what? Upstream. Because the river current is moving upstream, that means the river current and the direction of both A are in the same what? that both A and the same what direction. So the effective speed between the both A and the river current is subtraction. Both A and river current, because they are now in both. The river current is now upstream now. We are assuming that, let's assume it's upstream. What happens? We now say, okay, that it's now the same direction now. So it should be what? Addition. That subtraction. 15 minus what? 5. That's what we got to what? 10 kilometer what? Per hour. Am I communicating? Now, let's consider both B. Let's consider both B and the river current that is moving upstream. Both B is moving down, the river current is moving up. So it's what? Opposite. So you get addition. 20 plus 5, 25 kilometers per hour. Now, if you now want to now determine the effective speed between both A and both B, it's still the same what? 10 plus what? 25, which is what? 35 what? Kilometer per hour. Am I communicating? Is it clear? Is it clear? This thing you are looking sometimes takes you away from here. You're asking questions, I don't understand where they came from. It's clear that since she stopped her own now, she's pleased. Focus. Look at her. That the fair lady. She became CEO without pen and paper. She's now writing. Before she was just reading up and down. Immediately she put her own down. She became serious. Put that thing down. After you can make it. Okay. This is the assignment you are supposed to do since. So anyway, it's good. It's good, Sha. It's good the way we solve it. So if you see question like this, you can solve it, right? Right?
Yes.
Alright, put down. Let me look for that question on that. If you understood what I explained when the river current is the downstream, you can put this one down to 2 of us. It's just the same principle. Just know the one that should be addition and the one that should be what? Subtraction. Please, whatever you are doing in vector should be opposite. Here should be the what? Opposite. Know that one. Because we know that in our vector, the direction, if the direction is opposite, you do what? You subtract. Okay? If you what in the same direction, you do what? But here is what? Different. Know that, okay? Let me see if there's any other question we can solve here. If not, are we together? Or let me see if there's a question I can get from here. Please put this down. Let me see if there's a question I can get from here. If not, we move to another topic. One house, please. No noise. One house, please. Why do you always come late to lesson? You? Me. I don't come late to this first time I'm You don't know that let us start by 9 a.m. Then you come out early now, so you can beat the hold up. Don't you think so? Come out early. Hey. Now you have missed important. Did you do that assignment I gave you?
I think so. Let me check.
Okay, you think so?
Yes.
Are we together? Okay, something like that. You're not sure if we are together. Okay, let me see if I can see a question of motion.
I think I did. He's the one, he's not him. Maybe he's rubbish.
Oh no, there's not in this class, please. No noise, please. I beg you. No noise, please. Let's look at this question. Just put down this question.
Put down question.
What I do with you? Put down question. Keep that and put down question. Put down this question. A body can undergo the following types of motion.
The money.
A body. You're making noise. How you do it when you're making noise? A body can undergo the following types of motion. There's can there. A body can undergo. You don't say a body can undergoes. It's a wrong. So if you want to say undergoes, you remove that can. You can simply say a body undergoes, but it says a body can undergo. Or I put it down. A body can undergo the following types of motion, except go answer and answer that call. Answer the call. That's nothing to do. The body can undergo the following types of motion, except A, random. B, rotational. C, translational. D, relative. What's the answer? With reason, don't tell me D. As you tell me the answer, tell me why you chose the answer. The answer is what? Hey, stop that. You said the answer is what? Why D? Answer. I don't like that in your mouth. Why do you say D?
No, because relative motion depends on the observer's view. For this one, talking about the body.
You are getting there, but I want someone to hit it well. Someone should smoothen it.
It depends on
You have the idea, but I want someone that can explain it very well. You have the idea. Who can explain it well for us? Why D?
What was the name of the woman that took the glory?
Random, no. Who else? No. Nobody is talking here. What's going on here?
Because it's not a body that undergoes.
No. What you say? What? Say 50. Say it.
No. It's not a body that undergoes.
No confidence.
A body does not undergo with it.
How? Relative motion undergoes the body. What I say? Hey, nobody can say in this class. They copy the question. So, what is the right?
When
Very long stories.
I cannot. If the body cannot undergo relative motion like the other motion.
Like relative motion, like the only relative motion depends on the observer now.
We agree, but who can help us?
Now we should eat the question.
The answer is there. I agree, but I want to see if you're answering past questions. Let me tell you something. If you're answering past questions, don't just look at the answer and go. Try to find a reason for the answer, because the question can be twisted. They repeat questions every year, but they twist it. So if you don't know the reason why is the answer, if they twist it, you fail it again. Okay, now let me explain. All the other ones mentioned, a single body can undergo those ones. But for relative motion, it involves two bodies. Two bodies are not just a body. Two bodies. I say you tried, but I wanted you to smoothen it well. You have the idea. Remember here, I told you. Remember before I started teaching relative motion, I distinguish between absolute and what? Relative. Who among us were in the class when I introduced the topic? I distinguish between absolute and what? Relative. Absolute value and relative value. When you talk of relative value, you are comparing two different what? Things. Relative. And I will use your skin complexion as an example. I told you that if I two people, a guy and a boy and a girl, we are still here. I said this one, no, on the normal circumstances, one is dark, right? But when you now want to talk about the relative skin complexion to compare with somebody else, that person is fair. Who are who? So no, okay, you deny me now. No. Who was in the class that day? So that alone, before I teach a topic, I use what you see around to introduce it. That alone would have helped you to answer this question. Once you they are all motions, two of us, forms of what, types of what motion. But basically, a body alone on its own cannot undergo relative motion. Two bodies must be what? Involved, because you are comparing their parameters. You are comparing the speed of this with the what? Speed of this. You are comparing the displacement with the what? The displacement of the next what? Body. That's what is called what? Relative what? Motion. But oscillating motion, a single body can just be carry it out to two of us. Translational motion, a single body can do that. But in relative motion, two bodies must be what? Involved. So that's why that answer D is not answer. Sorry, I mean that's why D is the answer. Because it is the only one a body cannot be watched.
That's correct.
See how practical these questions are. A body, if you're not careful, you become confused then. Are we together? Yes, we are. All right, so that's a good question. Let me see if I can pick another one.
Now, what was the name of that one of Jacob
Okay. Hey, wait. You're making noise. Turn number 5. I'm trying to see if I can pick one more question. Then. Hello. Are we together? I think let's do you have any question so far? Do you have any question? Because I will want to switch over to the next subject. Ask fast. Ask fast. Please help me with your answer, please. I'm sweating. Give me your own. I want to use your own. Give me your own. I'll go back to you. No. Ask fast. What is what? Okay, someone asked a question. Hello? Someone asked a question. You can go back. He asked what if the current is like this? Don't worry. I think I will search for a question like that. In that case, we will solve it. I have already giving you a clue to solving such question. I told you that. Hello, are we together? No noise, please. I told you that. I told you that had it been, listen carefully. I told you that if the current moves if the current moves the boat in this direction, if the current is flow in this direction, the boat will be forced to move like this. Initially, the boat tried to go like this, but because of the current, it will move like this. I told you that you solve it using right angle, triangle, a lot of things are involved, which I told you with time. I'll look for a question in that form, then solve. Are we together? You know it, right?
No, I don't know it.
Thank you very much for your attention. We'll stop here for physics, please. Let's prepare atmosphere for chemistry. God bless you.